All right, so now we have random right triangle problems, two of them. All right, so A is 5. We're going to find the exact length of ACCB and the approximate length of AB. All right, so we got the 45, 45, 90 triangles. So there's rules. If you know the rules, these problems are incredibly easy. If you don't know the rules, these problems are incredibly hard. All right, 45, 45, 90 is a isosceles triangle, so that's also 5. And then we could use Pythagorean theorem, or we could remember that the hypotenuse is just times radical 2. It's just the leg times radical 2. All right, and here's a good suggestion. This is a serious suggestion. Google the rules. If you're studying, doing problems, whatever, just Google the rules. There's great resources on Google, or maybe even YouTube. All right, not that there's anything wrong with the information I provide, but just finding more resources is always a good idea. All right, you guys might say, well, Mr. Oswald, you're a phenomenal teacher, we don't need anything else. Or you might say, you're horrible, I need all the help I can get. Whatever it may be, just do what's best for you. All right, then over here we have a 30, 60, 90 triangle. So again, just knowing the rules, A is a short leg. The hypotenuse of the is just double the short leg. Remember, a 30, 60, 90 triangle is an equilateral triangle cut in half, so that's how we know that is 10. And then the long leg is just the short leg times radical 3. So that's 5 radical 3. All right, and then said find the approximate length of AB. This is just going to be 5 radical 3 plus 5. So just be careful plugging it into a calculator. Again, you'd have to close parentheses plus 5, or do 5 plus 5 radical 3, and then nonetheless close parentheses. 5 plus 5 radical 3, getting the approximate length. It's going to be about 13.66. All right. Find the length of X in this picture right here. So again, this is another 30, 60, 90 triangle. So all the rules we have are true, what we did above, but sometimes you just got to go in reverse, such that this is a long leg, and now we need the short leg. Well, instead of multiplying by radical 3, we're going to divide by radical 3, which you can also think of as multiplying by radical 3 over 3. It's the same rule, it just has a rationalized denominator. All right, that's why we practice rationalizing the denominator. So I'm going to pick doing this rule. So I'm going to multiply 6 by radical 3 over 3, which becomes, then I can do 6 divided by 3 as I'm simplifying, and I get 2 radical 3. All right, so I did that in reverse, but then it really just becomes a very similar problem. Now I got this hypotenuse right here. Remember, that's just going to be times 2 of the short leg, so it's going to be 4 radical 3. You just multiply the numbers on the outside. All right, so that's 4 radical 3. Now we have a 45, 45, 90 triangle, so that's 4 radical 3. It's all the same. And to find X, just utilizing the rules from before, it's going to be 4 radical 3, and you just multiply by radical 2. You multiply the numbers under the radical, and then we see if we can reduce. In this case, we cannot, so we are donezo. Hooray. So happy. Happy, happy. Simplify radicals, all right? Find largest square factor. Then you do square root of, we'll call that LSF, largest square factor. Then you're going to do the square root of the largest square factor. That's a little bit too big. Times the other factor. So again, sometimes if you're not listening to my video, if you're trying to listen to music right now, you're not going to know what OF means. And then simplify. All right. So Again, these are our factors: 1, 4, 9, 16, 25, 36. You got to know these, all right? It's what's expected out of you guys. Sometimes in math, you just got to know things, all right? You just got to memorize things. So we'll go all the way up to 10. All right, so 1 never helps, so I'm going to cross that out. Now 27, what we always do is we need half or less. That's always going to be our largest square factor. So half or less, well, that's really just makes it between 4 and 9, and it's 9. It's radical 9, the largest square factor. That's a really bad 9. Times the other factor, which would be radical 3, and then it's 3 radical 3. That's it. That's the answer. Doing 48. That means it's got to be 24 or less, because you know the largest square factor is going to be half of it or less. So we only got 4, 9, and 16 to pick from. In this case right here, it's 16. That's a largest square factor. And the other factor in this case would be 3. And then you simplify and it's just 4 radical 3. And then square root of 64. Don't overcomplicate things. Just remember the square root of 4 is an actual whole number. It's 8. All right, that's it right there. Doing these problems right here, you multiply mult outside, mult inside, and then simplify. All right, so literally all you have to do is 2 times 3, 6, 5 times 2, radical 10. This one cannot be simplified, so we're done. Radical 10 cannot be simplified. Over here, we're going to do 4 times 2, 8. Radical 2 times radical 2 is radical 4. Then simplify. Don't forget to simplify, but then we're going to get 8 times 2, or 16. And then rationalizing the denominator. All we got to do here is you just pick what's in the denominator. We consider this more simplified in math for reasons. All right, remember this is the number 1. This simplifies to 1. All right, so in math we don't like radicals in the denominator. So you pick what's in the radical, which is radical 2. Then you do radical 2 over radical 2, and then multiply straight across 2 radical 2. And then something we have to be good at is knowing that radical 2 times radical 2 is regular 2. And then you want to simplify again, 2 over 2, and that's just radical 2. So that's why we rationalize the denominator. It can make the number a little bit more familiar / easier to deal with / other reasons. So in this case over here, we got radical 3. So I'm going to multiply by radical 3 over radical 3. Multiply straight across, we get 4 radical 3 over 3, and that's it. Bada bing.